Hello, this is Ace Math, and this is Binomial Theorem. So, in this unit of Binomial Theorem, the ACE exam typically tests you on two sections. The first section just being what is Binomial Theorem. So this would be Binomial Theorem. I'm not quite sure how most people write it, but and then it would be like k to the n minus r. And then, so this is the first thing, just knowing how to use this formula. And then the second is just matching coefficients. So the reason binomial theorem came to be is due to this thing called Pascal Triangle, which basically just means what happens if we raise this to a certain power. Well, if we raise it to the if we raise it to the 0th power, so if we set n equal to 0, it's 1. If we set n equal to 1, it would be 1, 1. So this basically just means x plus 1. And we're just gonna omit the x. But then if we say n equals 2, then it would be x plus 1 squared, which is x squared plus 2x plus 1, which would be 1, 2, 1. So if n equals 3, it gets 1, 3, 3, 1, then it's 1, 4, 6, 4, 1. And basically, the way we get each new consecutive row is to just, for the ones, just write 1 down. They just come out of nowhere, basically. But for these numbers, you add these two up. So 3 plus 3 is 6, 1 plus 3 is 4, stuff like that. But the reason why this is very hated by a lot of people is because it's absolutely worthless and you can basically never use it, especially when you get into larger quantities of n, such as n equals 17. I'm not going to write down 17 rows because that's going to be 18 terms, and that's kind of ugly. So what we do instead is we do something called a Pascal's triangle. Let's say we do x plus 1 to the 4th power. Well, then that would be this row, because this is n equals 4. But what we can do instead is basically say, hey, let's use binomial theorem, which basically just means we're going to do a combination. And let's say I don't want all of these terms, because you'll never need all of these terms. Let's say I only need the middle term. This is the third term. Let's say the question asks me, what's the third term? Well, then we'll have to do 4 choose 3. Sorry, 4 choose 2. Because it starts at, it's 1, 4, 6, 4, 1. It starts at 4, choose 0, 4, choose 1, 4, choose 2, 4, choose 3, 4, choose 4. So the third term is 4, choose 2. And then we basically say this is x to what power? Second power, because it's that. And then 1 to the 4 minus 2 power, which would give 6x squared, which with Pascal's triangle gives you the same thing. So basically a way to use this really well is, let's say they ask what is 2x plus 3 to the 5th power, what are the first 3 terms in descending x. Well, then what we could do is basically say, hey, the first term will be 2x to the 5th, because it starts at 5 choose 0. But then if we move on, this is the first term. The second term would be the next power, so it would be 0. But then we want to decrease this by 1, because they're asking for descending x, and you can't get 2x to the 6th from a binomial expansion that's raised to the 5th power. So we say 2x to the 4th, and then we include this constant term now, because this is basically how it was, but we're just omitting that because, hey, that's just 1. So this is 3 to the 1st, and now the second will be 5 choose 2, 2x cubed, 3 squared. And this would be the third term. But now we got all of our terms, we just need to simplify them. So a combination, there's like a specific formula, but I don't really find it helpful because it's like annoying and you'll pretty much never need to know it until you reach higher levels. So as of now, the simplest way I think to teach it would just be, for example, let's do 6 choose 4. We basically do 6 factorial is just 6 times 5 times 4 times all the way to 1. But in this case, because there's a 4, only do 4 of those terms. So so it would be 6 times 5 times 4 times 3. So notice how there's 4 terms. Over, just do the bottom number factorial. So if you actually want the formula, it would be n factorial over n minus r factorial, but this is a lot simpler because this is 6 times 5 times 4 times 3 over 4 times 3 times 2 times 1. And so we can just simplify it, which gives 15. And another property I guess you should know is that 6 choose 4 is equal to 6 choose 2. So another more broader way to say this is n choose r equals n choose n minus r, because if we use this formula, if we just do n minus r in, you get the same value. And yeah, so that's basically how you do combinations. So with this, 5 choose 0 is 1, so 2x to the 5th is 32x to the 5th. 2x to the 4th, well 5 choose 1 is 5. 2x to the 4th is 16x to the 4th times 3. So that would be 240. So 240x to the 4th. I apologize if my math is wrong. I'm trying to do this in my head. I forgot to put my calculator. So now if we do 5 choose 2, that would be 10. 2x cubed is 8. 3 squared is 9. So if we multiply these up, you get 720, and your term of x is x cubed. So that's how you solve those types of questions. That's basically binomial theorem in a nutshell. So it basically depends how you want to memorize this, but I guess a more casual way of writing it is x to the r times k to the n minus r. I think that's how most people write it. I don't really memorize formulas. I typically just like to understand them more, but you're not ever going to need to recite this formula, and I'm pretty sure it's on your reference sheet. So that's your first section on binomial theorem. Your next thing is matching coefficients. So let's say this was part A of our first question. Now part B says, well then find 2x plus 3 to the 5th times, let's just say they want us to say 1 over x to the 4th plus, oh sorry, camera doesn't write it like that, x to the negative 4th plus x to the negative 3 plus x to the negative 2 plus 1. And so let's say they gave us this equation and they said find the coefficient of x. Okay, sorry, we flipped the table at the plus 1 term. So what they want you to do in these equations is, in part A, you solve for the first 3 terms. So we say this is 32 x to the 5th plus 240 x to the 4th plus 720 x cubed plus dot 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 times x to the negative 4th times x, sorry, not times, plus x to the negative 3rd plus x to the negative 2nd power. And so now they're saying find the coefficient of x. And what it means by coefficient matching is basically saying we're going to match certain terms so that we want our desired term. So let's say we match these 2 terms. If we match these 2 terms, you're not going to get a coefficient of x. You're going to get a coefficient of x to the 0th. So what we're going to say is that's not what we want. Instead, what we're going to do is match the coefficients. So if you match these 2, you get x. If you match these 2, you get x. If you match these 2, you get x. So what we're going to say is all the other terms are not necessary for this question. 32 x to the 5th, x to the negative 4th, 240 x to the 4th, x to the negative 3rd, 720 x cubed, x to the negative 2. And if we multiply these all out, you just get 32x, 240x, 720x. And so if they ask for the coefficient of x, now you just add them up. So the sum is 992 x. So the coefficient is 992. You don't really need to include this last step. They'll basically say, hey, accept 992x. But I guess this would be a final answer. So that's what it means by coefficient matching. It means match whatever coefficients you want to specifically match. So let's say instead we match these 2. That's not going to work because that's going to be a coefficient of a term of x to the 0th. If you match these 2, you get a term of x squared. If you match these two, you get a term of x squared, so you don't want that. If they instead ask for x squared, then yes, you would want that. But that's it for binomial theorem. Thank you for watching.